सो जैसा कि हमने लास्ट टाइम देखा था कि ऑलरेडी जो फ्री बॉडी डायग्राम का जो टेक्निक है तो वो हमने सीखा था लास्ट लेक्चर में। इसमें हमने ये सीखा था कि किस तरह से फ्री बॉडी डायग्राम्स ड्रॉ किए जा सकते हैं और यूजिंग दिस फ्री बॉडी डायग्राम्स हाउ कैन वी कंसिडर और हाउ कैन वी फाइंड आउट द आंसर्स टू द क्वेश्चंस। नाउ लेट अस कंटिन्यू। ओके, इसमें दो क्वेश्चंस हम और करेंगे इसी टाइप के, क्योंकि उसके अंदर कुछ बातें आपको इसमें से सीखने को मिलेगी। Yes, just consider an inclined plane like this. इस टाइप का inclined plane है सपोज, जिसका थीटा इतना एंगल बना हुआ है। ओके, और मान लो कि यहाँ पे एक पुली है और उस पुली के ऊपर से एक स्ट्रिंग पास होता है जो इस एक ब्लॉक को इधर सपोर्ट करता है, जिसका मास मान लेते हैं m1 है। ठीक है, और उसी पुली के ऊपर से वो स्ट्रिंग पास होके दूसरा मास एक सपोर्ट करता है दूसरे साइड में, जिसको हम बोल सकते हैं m2 is the mass of this another block here. Okay, and this is the angle theta here. Okay, now the question here is that how will you find out the acceleration of the whole system? No doubt if m2 is greater than m1, then the acceleration of this whole system will be like this. Okay, the m2 will just move downwards and m1 will move upwards, no doubt. But this will happen only when this m2 means force exerted by m2 is greater than m1, no doubt. But if suppose the reverse thing happens, that means the force exerted by m1 is greater than m2, then the acceleration of this whole system will be like this. Okay, so the string will just rotate in this way, so that this m1 will just slide down and m2 will just get lifted up like this. So both other possibilities are equally probable, no doubt. But here we have to understand that this m1 force exerted by m2 on the string is no doubt it is going to be m2 into g, no doubt. तो ये m2 into g इतना फोर्स इस m2 के ऊपर काम कर रहा है डाउनवर्ड डायरेक्शन में, जिसकी वजह से ये वो नीचे जाएगा बिल्कुल। लेकिन व्हाट इज द फोर्स एक्सर्टेड बाय m1 हियर? तो m1 के द्वारा एक्सर्ट किया हुआ जो फोर्स है वो निकालने के लिए हमको क्या करना पड़ेगा? देखो इस m1g को, चलो नो डाउट m1g विल बी एक्टिंग ऑन दिस m1 इन द डाउनवर्ड डायरेक्शन। तो ये m1 जो फोर्स है वो डाउनवर्ड डायरेक्शन में काम कर रहा होगा बिल्कुल, लेकिन दिस फोर्स विल हैव टू बी रिजॉल्व्ड इनटू टू कंपोनेंट्स हियर। तो अगर हम इन दो इस फोर्स को अगर दो अलग अलग कंपोनेंट्स में अगर रिजॉल्व करते हैं, देखो यहाँ पे जिसमें से करके देख लेते हैं ताकि समझ सके ठीक से, और कलर भी चेंज कर देते हैं ताकि आपको समझने में भी आसानी हो। Yes, so here we can just see that this m1g here can be resolved into two components, one of which will be along this perpendicular to the surface, and other one will actually be along this along the surface like this. And now in these two angles, अब ये इन दोनों एंगल्स में से कौन सा एंगल थीटा होगा तो समझ सकते हो। ठीक है, अभी इसके लिए हमको ये करना पड़ेगा कि अगर ये जो देखो इस तरह से ये हॉरिजॉन्टल और ये इंक्लाइन प्लेन, ठीक है, एक दूसरे के बीच में इनके बीच में थीटा इतना एंगल है। ठीक है, अभी इस हॉरिजॉन्टल को परपेंडिकुलर कौन है? तो ये वर्टिकल है, बराबर। और इस इंक्लाइन प्लेन को परपेंडिकुलर कौन है? ये वाला है लाइन। तो अभी ये तुमको पता होना चाहिए कि ये ऐसा डायग्राम हो गया जैसे कि ये एक हॉरिजॉन्टल लाइन और उसके साथ बना हुआ एक एंगल इंक्लाइन प्लेन का, जो कि एंगल थीटा है यहाँ पे, नो डाउट। बट अभी इसमें एक बात देखो कि इस हॉरिजॉन्टल को परपेंडिकुलर कौन है? वर्टिकल। और इस इंक्लाइन प्लेन को परपेंडिकुलर कौन है? ये नॉर्मल सपोज। तो इन दोनों के बीच में भी वही एंगल होगा, जो ये एंगल भी उतना ही होगा जो इन दोनों के बीच में होता है, बिकॉज देयर इज अ थ्योरम दैट the angle between two lines is always equal to the angle between their perpendiculars. That means if suppose this is a horizontal and this is an incline and they are having the angle theta between them, then horizontal का perpendicular मतलब vertical और इस incline का perpendicular मतलब ये वाला, तो इन दोनों के बीच में भी वही एंगल रहने वाला है थीटा. इवन ये भी थीटा होगा जरूर, क्योंकि ये इनमें से ये वाला जो है वो इस वाले को परपेंडिकुलर है और ये वाला जो दूसरा साइड है वो इस वाले को परपेंडिकुलर है. The angle between any two lines is always going to be perpendicular to the angle between their perpendiculars. तो दो लाइंस के बीच में का एंगल और उनके परपेंडिकुलर के बीच में का एंगल हमेशा सेम होता है. तो जबकि यहाँ पे इसमें और इसमें जो एंगल है, तो इसका परपेंडिकुलर जो कि ये है और इसका परपेंडिकुलर जो कि ये है, इन दोनों के बीच में वो ये एंगल होगा. This angle is going to be actually theta. We can just understand here from this logic. Okay, so if we just call this angle theta here, then we can just resolve this m1g into two components, one of which will be m1g into cos theta. Correct है, ये m1g cos theta हो गया. और दूसरा कंपोनेंट जो हम देख सकते हैं यहाँ पे, so it will actually be m1g into sin theta. करेक्ट है, ये दूसरा वाला कंपोनेंट हमको मिल गया. बिल्कुल. And once we get the two components, and we can understand here that this m1g cos theta component is just getting balanced by the normal reaction acting on this whole. तो ये जो normal reaction इस surface के ऊपर वजह से इसके ऊपर काम कर रहा है, तो इस normal reaction की वजह से ये m1g cos theta balance हो जाएगा. बिल्कुल. But the net unbalanced force acting on this first mass m1 here is actually going to be m1g sin theta. Okay, m1g sin theta is the only force acting on this in the downward direction. Okay, but this force is opposed by the tension now again. So on this mass m1, the tension in the string is acting in this direction. We can call it as T here, and even the same tension will be acting on this mass m2 here in the upward direction. So this is T here. So if suppose we can just consider here that by default that m2g is greater than the force exerted by m1g in pulling it in the backward direction, which is going to be m1g sin theta. Okay, तो अगर ये m2g m1g sin theta से बड़ा है, तो उस केस में क्या होगा कि ये जो m2 जो है वो डाउनवर्ड डायरेक्शन में एक्सेलरेट होगा और ये m1 जो है वो अपवर्ड डायरेक्शन में एक्सेलरेट होगा. ये इतने एक्सेलरेशन के साथ, आफ्टर ऑल द एक्सेलरेशन ऑफ द होल सिस्टम इज गोइंग टू बी कॉमन, नो डाउट. But the acceleration, if we consider it as a, then this a will be the acceleration of this whole system, and it will be a here. So in this case, the net pulling force will be once again we can just apply the formula for acceleration which we have learned last time in the last lecture. That is, acceleration is always equal to the net pulling force. Okay, this is the net pulling force that is to be divided by the net mass that is being pulled. Okay, so this is the formula. If you apply it carefully, then we can just get the formula for acceleration. That is, see here, what is the net pulling force m1g on this side and m1g sin theta, sorry, m2g on this side and m1g sin theta in this side. Correct? So both of these forces produce a resultant which is given by m2g minus m1g sin theta, and that is to be divided by the total mass that is being pulled, which is going to be m1 plus m2 as a whole. Correct है? तो total mass तो बदलने वाला नहीं है, total mass तो m1 plus m2 ही रहने वाला है, no doubt. So that's why we can just get this as a formula for acceleration. No doubt, we can also get it from the equations also, but this is from the shortcut method, no doubt. Now we can just find out the tension in the string by using the equation of Newton's second law of equation, Newton's second law अप्लाई करने से किसी भी एक बॉडी के ऊपर. सो आई थिंक दैट दिस m2 के ऊपर न्यूटन सेकंड लॉ अप्लाई करना थोड़ा इजी है, इसलिए हम उसके ऊपर अप्लाई करेंगे और उससे टेंशन निकाल सकेंगे. तो देखो, इफ यू जस्ट अप्लाई द न्यूटन सेकंड लॉ ऑन द बॉडी m of mass m2 here, what equation we can expect? See here. Yes, using Newton's second law on body m2. Okay, तो इससे क्या मिलेगा देखो, what is the net force acting on the body? Because Newton's second law tells us that the sum of all the forces acting on any body is always equal to mass into acceleration, no doubt. So what is the net force acting on the body? M2g in the downward direction and T in the upward direction. So we can just say that the net force is going to be in the downward direction because the system is getting accelerated in the downward direction. So we can just say that this M2g minus T is going to be the net force acting on the body, which has to be equal to the mass M2 of the body, that is multiplied with the acceleration of the whole system, which is common to this whole system. So using this formula, we can just try to express this T in terms of A. So M2G minus M2A comes out to be equal to T, right? ये T को उस तरफ भेज दिया और इस M2A को इस तरफ लाया, तो इसे हमको मिल गया. That means this T happens to be actually equal to M2 can be taken common, and what we are left with inside is G minus A as it is finally. And then we can just get this T to be simply equal to M2 as it is outside into G minus A, where A is going to be this whole thing here, which is to be replaced here. So if we do that, then we can be able to get that. This will be, अच्छा इसमें भी देखो acceleration ये जो हमको मिल रहा है यहाँ पे, तो इसमें से G कॉमन ले सकते कि नहीं न्यूमरेटर में से. तो न्यूमरेटर में से अगर G कॉमन लेते हैं तो M2 minus M1 sin theta will be left inside the bracket, and that is multiplied with G, and that is to be divided by M1 plus M2 kept as it is. So if we just replace this value of A here in this case, then we can be able to get this M2 minus M1 sin theta upon M1 plus M2 into G as it is. And then we can be able to take this G common from this whole bracket. So if we just take M2 as it is and G also outside the bracket, then we'll be able to get this 1 minus this whole thing is going to be M2 minus M1 sin theta, and that is to be divided by M1 plus M2 as it is. Okay, and then we can be able to take the LCM now and get this tension finally, which is going to be M2G into bracket. अब यहाँ पे LCM दे लेंगे तो यहाँ पे क्या आएगा? So वो बनेगा M1 plus M2 minus bracket में आ रहा है M2 minus M1 sin theta as it is, and this whole is to be divided by M1 plus M2 as it is. Okay, so this is M1 plus M2 kept in the denominator as it is, and then now we can just open this bracket because this minus sign will just distribute it, and then we can be able to get the tension T in the string, which is to be equal to M2G into bracket में क्या आएगा देखो M1 plus M2 minus M2 minus of minus becomes plus, and here it will be M1 sin theta kept as it is, right? And then this will be actually divided by M1 plus M2 as it is here in this way, and then we can be able to cancel out this M2 and minus M2 from the numerator and take this M1 common from this whole both of the terms in the numerator, right? So that we can be able to get this T to be simply equal to M2 into G into M1 out, and what we left inside is 1 plus sin theta. Okay, 1 plus sin theta, and that is to be whole divided by M1 plus M2, which can also be written in the similar simple way that T is equal to M1 M2 upon M1 plus M2. Once again, the same factor which appears naturally every times in these expressions is this type of expressions into 1 plus sin theta, and that is to be whole multiplied by G. So this happens to be actually the final formula for the tension in the string in this case, remember. And this tension in the string can also be written to be simply equal to mu times 1 plus sin theta upon into G. Here we can understand here that how this mu is important and how this mu is significant here in every case. So हर एक example के अंदर हमको पता चल रहा है कि mu कितना important है, और इसी के चलते और एक बात हम यहाँ पे नोट कर सकते हैं कि even we can just get the tension in the string by applying the Newton's second law on this body of mass M1 also. इस m1 के ऊपर अगर हम न्यूटन सेकेंड लॉ अप्लाई करते हैं तो फिर बताओ क्या इक्वेशन हमको मिल सकता है। देखो, so if you just apply the Newton's second law on the body of mass m1, then we can be able to get this equation as तो देखो इस बॉडी m1 के लिए कैसे इक्वेशन यूज करेंगे। एक तरफ m1 sin थीटा फोर्स काम कर रहा है इस तरफ इस डायरेक्शन में और t डायरेक्शन इस डायरेक्शन में काम कर रहा है, but obviously we can say that this t is going to be greater than this m1g sin theta. Just why? Because the acceleration of the whole system is getting in the upward direction. ये पूरा सा सिस्टम है, ये a एक्सेलरेशन के साथ ऊपर की तरफ जा रहा है, इसलिए ये जो नेट फोर्स है तो वो ऊपर की तरफ होगा जरूर, इसलिए t must be greater than m1g sin theta. And if we just find out the net force, okay, because we want to apply the Newton's second law for the body of mass m1, then we can be able to get that this t minus m1g sin theta, that is the net force acting on this body of mass m1, must be equal to the mass of the body m1 into acceleration of the whole system, which is common, right? And then we can just be able to get this t by just transferring this m1g sin theta in that side, so that we get this m1 can be taken common and we'll be left with simply a plus g sin theta. Okay, a plus g sin theta. And once again, if we just replace this value of a here, ये जो a का वैल्यू है यहाँ पे, वो अगर सीधा हमने यहाँ पे a के बदले डाल दिया इधर, तो ऑटोमेटिकली हमको यही फॉर्मूला मिल जाएगा। देखो यही फॉर्मूला हमको मिल जाएगा फिर से टेंशन का, सॉरी ये वाला फॉर्मूला, जो यही फॉर्मूला हमको मिल जाएगा फिर से टेंशन का, जो हमको ऑलरेडी मिला हुआ है। ओके, सो देयर इज नो point in solving it further because we already know that the answer is going to get this same only. You can just check and verify on your own if you want afterwards. ठीक है, तो बाद में तुम चल के ये वेरीफाई करके देख सकते हो आराम से कि ये जो a का वैल्यू है वो यहाँ पे डालना पड़ेगा, फिर से तुमको एलसीएम वगैरह निकालना पड़ेगा, फिर से कुछ टर्म्स कैंसिल होंगे न्यूमरेटर में और जो बचेंगे तो उससे हमको यही इक्वेशन फिर से मिल जाएगा फॉर द टेंशन. But we can just understand the tension in the string is obtained to be mu into g as it is, but this extra term is getting replaced by 1 plus sin theta. That is we have to remember this only. Okay, or just forget about this formula for the tension, just remember the formula for acceleration, and that is also we can just find out in 2 minutes in 3 steps by using this basic formula which you already know. तो इस फॉर्मूला को यूज करके एक्सेलरेशन का फॉर्मूला डिराइव करके लो. Once we get the formula for acceleration, we can just apply the Newton's second law on any one of the bodies out of the two, and like this, and put the value of acceleration in that formula so as to get the tension finally. ठीक है, तो न्यूमेरिकल के अंदर तुम ये टेक्निक यूज कर सकते हो डायरेक्ट. ठीक है, नॉट अ फॉर्मूला एक्चुअली, बट यू कैन जस्ट यूज द टेक्निक as it is in any numerical of this type, obviously. Again, we can just see in another example of this same type in which only the inclined plane will be not single, but there will be 2 inclined planes like this. Okay, so suppose that there are 2 inclined planes in this way. ये एक इंक्लाइंड प्लेन है और ये वाला एक इंक्लाइंड प्लेन है. And suppose that both of these inclined planes are just at an angles alpha and beta respectively with respect to horizontal. Okay, तो horizontal के साथ अल्फा और बीटा ये इतने एंगल्स वो कर रहे हैं, और मान लो कि यहाँ पे एक पुली हमने बिठा के रखा है. Okay, suppose this is the pulley. Yes, and then we can just see that a string will be connected here. Okay, so this is the pulley, and a string will be connected here, and it will support a mass m1 at this one end. Okay, this is the mass m1, you can see, and the same string just passes over pulley and just supports another mass m2 on this other end. Suppose here ये जो मास है वो m2 मास है. ओके, अभी इसमें देखो फिर से एक बार हम ये बात कर सकते हैं. इफ यू वांट यू कैन जस्ट enlarge this here in order to analyze. Okay, तो देखो यहाँ पे क्या हो रहा है कि yes, if you just see carefully, what are the forces acting on this m1 here? So the first force acting on this m1 is going to be m1g, which is going to be in the downward direction, right? So this is the force m1g. Okay, and this force m1g can actually be divided into two components as before. जैसे हमने अभी किया था तो वैसे ही हम यहाँ पे दो कंपोनेंट्स में इसको रिजॉल्व कर देंगे, जिसमें से एक कंपोनेंट एक्चुअली इस सरफेस के अलोंग आएगा, ये हो गया एक कंपोनेंट, और दूसरा कंपोनेंट उसका बनेगा इस तरफ, perpendicular to that surface of inclined plane, obviously. Okay, so this is the second component, and since this angle is alpha here, so it is the angle between the horizontal and inclined plane. But horizontal का perpendicular कौन है? Vertical. और इस inclined plane का perpendicular कौन है? ये वाला line, right? तो इसलिए इन दोनों के बीच में भी वही एंगल होगा जो इन sorry. Okay, so this second component becomes m1g sin alpha here, no doubt. चलो ठीक है. So in the same way we can just resolve this, the force acting on this m2 also. Okay, so this force acting on m2 can also be resolved in the similar way. See here, the force acting on m2 will be one of which is m2g sin m2g here. तो ये एक फोर्स जो है वो तो उसके ऊपर काम करेगा डाउनवर्ड डायरेक्शन में, जो उसका खुद का वेट होगा, नो डाउट. लेकिन अभी इसको भी हम दो कंपोनेंट्स में रिजॉल्व कर सकते हैं, जो कि एक उसका इस तरफ आएगा सरफेस के अलोंग, और दूसरा कंपोनेंट उसका रहेगा सरफेस के परपेंडिकुलर डायरेक्शन में. ठीक है, मींस एट राइट एंगल्स टू द सरफेस, नो डाउट. बट सरफेस इटसेल्फ इज मेकिंग एन एंगल बीटा विद द इंक्लाइन, राइट? तो इंक्लाइन जो है वो सरफेस के साथ बीटा इतना एंगल कर रहा है. तो अभी हॉरिजॉन्टल का परपेंडिकुलर कौन है? ये वर्टिकल. और इस इंक्लाइन का परपेंडिकुलर कौन है? जरूर ये वाला साइड, मतलब ये वाला. ठीक है ना? तो इसलिए इन दोनों के बीच में भी उतना ही एंगल होगा जितना इन दोनों के बीच में है. तो इसलिए ये बीटा एंगल जो है वो यहाँ पे अपीयर करेगा. हम बोल सकते हैं दिस विल एक्चुअली बी इक्वल टू बीटा, नो डाउट. एंड वंस वी गेट दिस एज बीटा, we can just be easily resolve the m2g in two components now. So how can we resolve this m2g? So this angle, this will be actually m2g cos beta, you can say. Okay, so this will be m2g cos beta, and at the same time this component here, another one, will actually be m2g into beta. correct है? So these are the two components of this M2G here, no doubt. Okay, and now we can just resolve, or we can just analyze this situation. Yes. Now just see, अभी यहाँ पे resolve करके तो हमारा पूरा हो गया, no doubt. Now we will have to draw the free body diagram of each of these bodies. If you just try to draw the free body diagrams, then we'll be able to get this for M1. अच्छा, सबसे पहले मुझे बताओ, if suppose यहाँ पे दो cases बनते हैं, if M1G sin alpha, मतलब ये वाला फोर्स जो है वो अगर इस वाले फोर्स से, मतलब M2G sin बीटा से अगर बड़ा है, तो उस केस में एक्सेलरेशन जो है उस सिस्टम का इस डायरेक्शन में होगा. The body will rotate or pulley will rotate in such a way in a anti-clockwise direction, so that is M1 will go down and M2 will slide up, okay, along the inclined planes, no doubt. But if suppose the reverse thing happens, if suppose by chance this M2G sin beta is going to be greater than this M1G sin alpha here, then this pulley will just rotate in the clockwise direction, clockwise direction like this, so that the acceleration of this whole system will be in this way, so that this M2 will just slide along the inclined downwards, and this M1 will slide up along this inclined in this way. ठीक है, तो इस तरह से ये होगा, सिचुएशन होगा. बट अभी चलो ठीक है, if suppose by default हमको कुछ ना कुछ assume तो करना पड़ेगा जरूर. So just let us assume that M1G sin alpha is just greater than the force exerted by this M2G along the plane, that is sin beta, M2G into sin beta. Okay, अगर ऐसा है तो फिर क्या होगा कि the pulley will slide, pulley will roll in the anti-clockwise direction, and hence the acceleration will of the whole system will be in this direction in such a way that this M1 will slide down and M2 will just slide up. Okay, तो ये हमको याद रखना है. ठीक है, अगर ऐसा है तो उस केस में फिर what will be the net force acting on this whole system, and what is the net mass that is being pulled, because we have the formula for acceleration, that is the net force acting on the whole system. You can say net pulling force here. Okay, इसको हम बोल सकते हैं net pulling force, and that is to be divided by the net mass that is being pulled. ये फॉर्मूला अच्छी तरह से याद रख लो, कई बार हमको ये यूज करने पड़ रहा है. Okay, so what is the acceleration then? So acceleration will actually be equal to, अब देखो net force pulling force कितना है. If you just stretch this string, then one end of the string is getting stretched by this force M1G sin alpha, and other end is getting stretched by this force, that is M2G sin beta, right? So the net force pulling this whole system will actually be the difference of this M1G sin alpha and M2G sin beta, right? So that's why we can just have this M1G sin alpha minus M2G sin beta in the numerator. That is going to be the net pulling force, which has to be divided by the net mass that is being pulled, which has to be M1 plus M2 only, no option. And then we can be able to get the total net acceleration of this whole system. If we just take G common from the numerator here, then we can get this M1 sin alpha minus M2 cos alpha, M2 sin beta. That is to be divided by M1 plus M2 kept as it is, and this whole thing to be multiplied by G, that is acceleration due to gravity. So this is actually going to be the formula for acceleration. And as we already know that once we get the acceleration, there is no difficulty in finding the tension. We can find out the tension easily by just applying the Newton's second law on any one of the bodies, either M1 or M2. If we use Newton's second law on body M1, okay, तो क्या मिलता है हमको? देखो, एक तो इसके ऊपर देखो कौन से फोर्सेस काम कर रहे हैं. M1G sin alpha फोर्स काम कर रहा है इस तरफ, जबकि tension in the string is acting in this direction. So what is the net force going to be on this body of mass m1? We can just say this will be m1g sin alpha minus tension T is going to be actually equal to m1 into A, right? This is the equation number 1, which is obtained by applying the Newton's second law on the body m2. If we use the same, that is Newton's second law on the body m1, m2 suppose, तो m2 के ऊपर अगर हमने ये यूज किया तो देखो हमको क्या मिलेगा. इसके ऊपर भी वही दो फोर्सेस काम कर रहे हैं, एक तो m2g sin बीटा और दूसरी तरफ टेंशन in this string in this direction, right? But in this case tension has to be greater than m2g sin beta, right? Because the body is moving in the upward direction here, so that's why the tension must be greater. So what we expect here is T minus m2g sin beta should be equal to the mass of that body, that is m2, into the acceleration of the whole system, and this we can record it as equation number 2, okay, which is obtained by applying Newton's second law on the second body. And now the next step here is put the value of acceleration from this equation in any one of these equation, here or here. We can just get the expression for tension anyways. So if we just shuffle these terms, then we can just get the tension here from this equation to be simply equal to T equal to, so देखो यहाँ पे m1 into g sin alpha, and that should be minus m1 into A, ये हमको मिल रहा है. And T can be finally written as, if we just take m1 g sin alpha kept as it is minus m1 into, अब यहाँ पे देखो A का जो वैल्यू है वो हमको यहाँ पे ये मिला हुआ है ऑलरेडी, ये पूरा वैल्यू हमको इधर रखना है A के जगह पे. तो इससे हमको ये क्या मिलेगा, देखो इससे this m1 should be multiplied with, this will be here m1 sin alpha minus m2 sin beta in the numerator divided by m1 plus m2 the denominator, and that is to be multiplied with g as it is, okay. And then we can be able to get this m1 here outside the bracket. Even g can also be taken outside the bracket, right? So if we just get m1 and g out the bracket, so इस bracket के बाहर अगर हमने ले लिया m1g को, तो देखो अंदर में क्या मिलेगा, फर्स्ट ब्रैकेट में से सिर्फ sin alpha बच रहा है, so only sin alpha will be left inside, and in the from the second bracket what we can have is m1 बाहर गया, g भी बाहर चला गया, बाकी अंदर में बचेगा m1 sin alpha plus, sorry, minus m2 sin beta, right? Yes, and that is to be divided by m1 plus m2, no doubt. And then we can just take the LCM now. तो अगर हम यहाँ पे LCM ले लेंगे तो देखो क्या होगा, yes. So after taking LCM, we can just get this m1g as it is, and here it will be sin alpha must be multiplied by the bracket m1 plus m2 and minus sign here in between, and it will be m1 sin alpha minus m2 sin beta inside the bracket, okay. And this whole thing is to be divided by m1 plus m2 as it is, okay. So this is your m1 plus m2, no doubt. And then we can just be able to get that m1g kept as it is into, what is this here, so if you just open the bracket, then we can just be able to get that m1 into sin alpha, okay, plus here it is m2 into sin alpha, okay, minus ये जो है ये डिस्ट्रीब्यूट होगा माइनस साइन अंदर, तो ये बनेगा माइनस ऑफ m1 sin alpha which will get cancelled, and minus of minus plus, here it is going to be m2 into sine beta, kept as it is, and this whole thing is to be divided by m1 plus m2 again. Yes, and now we can just be able to get cancelled with this m1 sin alpha completely. तो अगर ये पूरा कैंसिल कर देंगे तो ये जो दो टर्म्स बचे हुए हैं इसमें से ये m2 और ये m2 कॉमन निकाला जा सकता है, जिससे हमको ये मिलेगा यहाँ पे टेंशन इन द स्ट्रिंग टू बी सिंपली इक्वल टू m1 into g already is out and this m2 is also getting outside, so this m2 is kept outside and what we are left inside is, so m2 बाहर गया तो अंदर में क्या बचेगा, देखो sin of alpha plus here it is sin of beta, and that is to be whole divided by m1 plus m2 kept as it is, and then we can be able to get express this in a systematic way, that is t is equal to, again it will be m1 m2 upon m1 plus m2, and that is to be multiplied with sin alpha plus sin beta into g, which is already there. And even if you just want to express this in terms of our concept of reduced mass, which already we have studied in last lecture also, then we can also be able to do this. तो यहाँ पे अगर इस m1 m2 upon m1 plus m2 इसको अगर हम mu से reduce कर देते हैं, mu से अगर replace करते हैं, तो this tension in the string can be supposed to be mu into sin alpha plus sin beta, and that is to be multiplied with g. This is the direct formula for the tension which can be used in this type of situation. Or just don't worry about this formula, just remember this formula here, or just remember the technique how to develop this formula, that is the net pulling force upon net mass that is being pulled. And once we get the acceleration from this equation, we can just put the value of acceleration in the formula obtained by Newton's second law on any one of the bodies, either m1 or m2. And believe me that if we put the value of a in the equation obtained by applying Newton's second law on this body of mass m2 also, then also we are going to get the same value for tension, no doubt. ठीक है, ये टेंशन के लिए हमको सेम ही वैल्यू मिलेगा, उसमें कोई डिफरेंस नहीं है, याद रखो ठीक से. So that's why you can just get this as a final value of tension. बिल्कुल, तो इस तरह से टेंशन का वैल्यू हम निकाल सकते हैं आराम से. And no doubt we can just remember this formula for tension also. अगर तुमको चाहिए तो ये टेंशन का फॉर्मूला लर्न करके भी रख सकते हो, बिल्कुल. If we just study comparatively, एक 2 मिनट में अगर हम एक कंपेरेटिव स्टडी करेंगे ना, तो हमको पता चलेगा. देखो ठीक से, सपोज जब वर्टिकल पुली होता है, सपोज एक पुली जो है वो बिल्कुल वर्टिकल है. देखो अगर ऐसा सिचुएशन है, मैं यहाँ पे 3 सिचुएशंस ड्रॉ करता हूँ. देखो ठीक से, तीनों सिचुएशंस के अंदर देखो फर्स्ट सिचुएशन में पुली वर्टिकल है, बट स्ट्रिंग जो है तो वो उसको इस तरह से लटक रहा है. The first mass is just here and the second mass is just suspended here, but in the second case the pulley is just clamped on an inclined plane like this. ठीक है, inclined surface पे वो रखा हुआ है, लेकिन एक ही surface inclined है उसका, बस दूसरा surface inclined नहीं है. और तीसरा situation जिसके अंदर हम देख सकते हैं कि pulley is kept on a surface in which both of these surfaces are inclined only, like this, which are inclined at different angles, maybe alpha and beta. Okay, और यहाँ पे एक ही एंगल है, इसलिए उसको अल्फा या बीटा बोलने की जरूरत ही नहीं है, उसको हम डायरेक्ट थीटा बोल सकते हैं, बिल्कुल. So if we just remember the most general formula for the tension, acceleration and the tension in the string here in this case, तो यहाँ पे जो formula आपको मिलता है acceleration का, याद है क्या है? अभी हमने उसको derive किया. If suppose there is a mass m1 which is suspended in this end of the string here, and if suppose the mass of m2 is suspended on the other end of the string here, यहाँ पे m2 mass लटक रहा है, तो उस केस में हम बोल सकते हैं कि m1 sin alpha minus m2 sin beta, that is to be divided by m1 plus m2, and this whole thing is to be multiplied with g. This is the formula for acceleration. And if you want tension, then tension happens to be simply equal to mu into sin alpha plus sin beta into g. That's it. So this is the formula for finding the tension in this case. Okay. So if you just remember these two formulae only, then also these formulas in these two situations can be just obtained directly using the analogy. Just see here. अभी इस केस में ये फॉर्मूला कैसे डेवलप होगा या मॉडिफाई होगा, देखो ठीक से। तो एक्सेलरेशन के लिए जो फॉर्मूला हमको मिलने वाला है, तो उसके अंदर ये सेम रहेगा। यहाँ पे सिर्फ यहाँ पे क्या है ना, अल्फा जो है इट इज गेटिंग रिप्लेस्ड बाय थीटा हियर, बिकॉज one inclined plane is theta. Obviously the body is there, one body is just clamped at the one end of the string, and other body here is just suspended in air at the other end. Okay, so here in this case the formula will get modified in this such a way that this alpha has to be replaced by theta here in this case. But what is beta in this case? If you just see, beta is the angle of inclination of this second inclined plane, right? But here in this case, the second inclined plane is just vertical, right? Which is making an angle of 90 degree with the horizontal. That means we can just put this value of beta as 90 degree here in this case. So automatically what we get is simply m1 into sin alpha or theta minus m2 into sin beta. What is sin beta? Beta is going to be 90, and sin 90 we know it is 1. So no need to write 1. अगर लिखा भी नहीं लिखा तो भी चल जाएगा, क्योंकि m2 into 1 becomes m2 only, and that is whole thing is to be divided by m1 plus m2, and this is to be multiplied with g, that is acceleration due to gravity. And in the same way tension also, tension का भी हम वही कर सकते हैं। देखो tension is equal to mu as it is into, here it is sin alpha plus what is sin beta? Beta is going to be 90, so sin beta happens to be 1, and hence you can just get this as sin beta is 1. So sin alpha plus 1 is left inside the bracket, and g is getting multiplied here. And in this case here, if we just consider this body as a mass m1 and this body of mass m2, then we can just be able to get the acceleration in this case to be simply equal to, अब देखो यहाँ पे जो पूरा दोनों surfaces vertical है, तो यहाँ पे alpha and beta both are considered to be 90 each, and since they are 90, we can just get that अगर यहाँ पे अल्फा के बदले 90 डाल दो, ये बीटा के बदले भी 90 डाल दो, तो यहाँ पे साइन अल्फा क्या बनेगा? 1 बनेगा, और साइन बीटा भी 1 बन जाएगा। तो m1 into 1 becomes m1 only, and m2 into 1 becomes m2 only, and hence we can just be able to get the final result as m1 minus m2 in the numerator, and that is to be divided by m1 plus m2, and that is to be whole multiplied with g, which is already there, that is acceleration. And if we want tension in the string, then we can just use this general formula for that and put this value of alpha as well as beta to be 90 each. So if we just put the values of alpha and beta as 90, then we can just be able to get that sin alpha becomes 1, sin beta becomes 1, and 1 plus 1 becomes 2, and hence we will replace his cells mu into 1 plus 1 into g, which happens to be actually t is equal to 2 mu g, which is already we have derived this result previously. So if we just check, these are the same results which we have already obtained in the last slides. If we see carefully, ये तो चलो ये तो हमने already derive किया ही है, no doubt. But इसके अलावा ये वाला जो result था इसके पहले वाले screen पे जो हमने derive किया था, वो भी तुम देख सकते हो आराम से किस तरह से हमने derive किया। Yes, यहाँ पे हमको जो tension है स्ट्रिंग के अंदर का फाइनली वो जो मिला, तो वो ये इक्वेशन से मिल रहा है, ये वाला इक्वेशन दिख रहा है। तो ये म्यू इंटू 1 प्लस साइन थीटा इंटू जी, ये जो हमको मिला था वो वही इक्वेशन है जो हमने यहाँ पे अभी डिराइव किया था, ठीक है। सो दिस इज ऑल अबाउट द फ्री बॉडी डायग्राम्स। सो यहाँ पे ये टॉपिक जो है फ्री बॉडी डायग्राम वाला यहाँ पे खत्म होता है। सो नेक्स्ट लेक्चर में हम इसका आगे का जो टॉपिक है, इसी चैप्टर के अंदर इसका आगे का जो टॉपिक है जो कि अबाउट द कंसेप्ट ऑफ इम्पल्स एंड द कंसेप्ट ऑफ लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम, and the concept of elastic and inelastic collisions, and the expression for the loss of energy in case of inelastic collisions. We'll discuss it in the next lecture in tomorrow. Okay, so that's all for this lecture. Let us stop this lecture here, and thank you all of you.